Hi and welcome to a new build review episode on my channel. Today I'm going to talk about the current build I fly with my GEP-AX5 frame from GEP-RC, all the components I installed and how it's wired up and everything else you need to know. So we start at the outside. So on the top we have the GoPro Session 5, which is my absolutely trusty HD cam for FPV footage. Works great, had already a lot of hard crashes, is still working. It already lost its back aluminium plate, but the camera is still working well, so I will keep up with this cam to make my HD footage. The FPV cam I use is the Foxeer Arrow V3. What I really like on this cam are two reasons. The first one is the screw mount system. You have a metallic case, it's not a plastic case, and the big point is that the screw holes are super rigid, so you can tighten and loosen your screws as often as you want, and the holes will keep in good shape. As you know from some run cams or other brands, there are problems with the plastic case that your screw holes are getting in bad shape pretty quick. After a few times tighten it and loosen it, the screws, the holes are in bad shape and you're not able anymore to fix your camera well. The second reason that I like on this camera is the lens. It gives you almost the same field of view which has the GoPro if you set the GoPro on wide angle. So I think it would be around 170 degrees. I really like a wide field of view, and this lens makes this job very well. Then we come to a first modification of the frame. If you buy the frame, there is this 3D printed plastic or rubber part. This goes from the top where the GoPro sits on, goes down and down to this spacer here. And I just cut it down just to the piece which the GoPro sits on it. And instead of the rubber piece which doesn't protect your cam real well, I drilled up a little bit these two holes on both sides. There was already holes or little holes like these here. You have to drill them up to 3 millimeters, and then you can add a second spacer which protects your FPV cam pretty well from hard impacts at the front. So like this, as you can see, the FPV cam is pretty well protected from the carbon parts and the spacers and the 3D printed part around the camera lens. And another good point of this modification is your camera lens can move a bit, but it's around 15 degrees or something. If we go down, this is the lowest angle you can get, and if we go up, this is the maximum angle you can get. So in case of a crash and you want to go on with flying without resetting your cam, you're still able to fly. The lens can move a bit, but you won't have a strange angle that makes it impossible to go on flying without coming down and replacing the lens. So this is also a nice feature of this second spacer you have here to protect your lens from downward angles or whatever. The props I use at the moment are the HQ's 5045 3-blade durable polycarbonate props, and I really like them because they're almost unbreakable. All these props you can see here already had some hard crashes in the woods, also on concrete, and they still work, have some scratches and things, but you're still able to fly with almost no vibrations, and I like these props. because of their durability and also the flight performance. My current motors are the Lumineers RX220611 with 2350 kVs. I'm not a fan of really high kVs just because I don't need to race, and for freestyle it's okay to go with 2300 or 2400 kVs or something between. They work pretty nice. Performance is okay. Performance is very good. There are a few things I don't like on these motors. One is the extremely short shaft. So if you use a propeller which is a little bit higher around the shaft, and you don't need these low profile nuts from Lumineer, but a regular nut like this one. As you can see, also with these low propeller center is pretty close to fix the nut well on the shaft. So if you go with a thicker propeller like the GEP-AX5, there you're really in trouble to fix your nut well on the nut, because the self-locking part doesn't touch the shaft of your motor, and the nut comes really easy loose from your shaft, and that's a point what I don't like. Another point is these super thin cables. These are lightweight, that's all nice, but I already broke one of my cables just beside the soldering point on the 4In1 Esc, and I have no idea why. There were some hits for sure, but not really extreme crashes which hit directly on the cable or whatever, and one of these cable broke, and that's not what I like. I prefer really strong hardware which also accepts a lot of crashes and don't break, and that's also a little disappointment on these motors. And one of these motors even lost one of its magnets after a few decent crashes, and that's also a negative point on these motors. These are one of the most expensive motors you can get on the market, and I expect more of a motor which is around $30. And so yeah, performance, lightweight, everything is great, but the construction could be better. And also the aluminium shaft has the problem that not every prop sits absolutely tight on the shaft. That means if you put it on and you can spin the prop without spinning the motor, so it fits loose on the shaft, there is potential for vibrations. So only if your prop sits tight on your shaft, you're sure that you won't have unnecessary vibrations with your prop and motor combination. So I'm sorry Lumineer, but these are a few negative points for this motor. Performance, as I already said, is good, but the construction itself, there are better motors on the market in my opinion. Then let's talk about the FPV antenna I use. It's Foxeer right-handed circular polarized antenna. I really like these antennas because they are super strong. Already some hard crashes, and the case is still in perfect condition. The whole antenna is still in perfect condition, and I prefer to go with the longer antenna version just because the stubby antennas will be covered more from the frame, from the carbon frame, just because they are closer to the frame. In case of turning your quad and whatever, it's more often covered from the frame. The frame is between your transmitter and your receiver antenna and your VTX antenna, so you lose more of your good quality picture of your FPV picture if you use the stubby antennas instead of the longer versions. It's a little bit more weight, but super crash resistant. I really like this thing. And how I fixed it is just I used these standard holes on the top plate of the frame just to cable ties around it and to isolate the SMA plug from the frame. It's just some electric tape around the antenna plug, and then you're good to go with a clean isolated antenna on your carbon frame. The RC antennas are pretty simple installed. It's just this spacer you have inside of your GEP-AX5 frame, and there are two cable ties around it. One goes upwards, one goes downwards, and like this you have a nice around 90 degrees angle for your two diversity RC receiver antennas, and like this you have fantastic range. I use a Futaba fast system, and like this for a racing quad it's almost unlimited range with this receiver antenna setup. Then let's have a look inside the frame, the components I use inside. Let's start with Esc. This is luminaire 35 amps 4-in-1 Esc, and it's good to know that it's the exact same Esc as the Sunrise Cicada 35 amp 4-in-1 Esc. Really the exactly same layout of all the electronics and the plug, everything's exactly the same. This Esc has no back, so no 5 volt out, no 12 volt out, and that's the reason why I use a Pololu step down regulator. It's a 12 volt step down regulator with 600 milliamps. This is okay if you power up your VTX and your FPV cam with clean power from your Pololu step down regulator. Then we have the FC on top of the Esc. This is the Furious FPV 4In1 flight controller. So far I'm really happy with it. It comes completely soft mounted with these silicon rubber rings. They go through the electronics plate, so this makes sure that you can't get any vibration from your frame to the FC. And what I also did, I use nylon screws instead of steel screws, just to get a little bit more the possibility to move the FC, and like this it's also reducing some vibrations. The screws are mounted from top to the bottom, so if you have a look on the bottom side of the frame, as you can see I use only two steel screws to holding the arms, and the third hole is just showing a little bit of the last bit of the nylon screw, which comes from top to down. And in this red aluminium part you have also the winding which takes the screw, so this makes it possible to screw your nylon screw upside down through this red aluminium part which holds the screw, and you don't need any nuts on the downside to keep the screw in place. So I really like this solution. It looks nice and clean, and it's also, there's no possibility to damage your nylon screw on the bottom of your frame because of a crash or a hard landing. You can cut off your head of the nylon screw, and if you screw it from top to the bottom, your nylon screw is extremely well protected, and the whole thing looks super clean. There's just one more thing I have to say about FC, the 4In1 FC. If you use this kind of 4-in-1 Esc, the wiring you can see in the manual is wrong. So your harness from your Esc, which goes to these 5 pins on the lower side of the FC, is completely wrong in the manual. So be careful, don't follow the order of the cables which is showed in the manual of the FC, but the right order is, if we start on this side here, we have yellow, then we have green, then we have blue, then we have orange, and the last one is ground. So make sure that you go for this order: yellow, green, blue, orange and ground. If you do anything else, your motors won't be on the right place for Betaflight, and that's you won't be able to fly like this. So follow this order and you will be fine. Your quad will be working perfectly as you expected. Then I have a buzzer on it, then just to make it more easy for me to recover my quad if it crashes into high grass or in the woods or whatever. It makes it much easier to get it back. And then let's have a look at the receiver. It's a Futaba receiver. I have to be honest, I cannot tell you the number, the model of this receiver, but it's a modified receiver, and I will do a short separate tech stuff video which shows you the modification, the weight reduction and the size reduction I did on this receiver, just to make it much more easier to install it in small race quad frames like this one is. It's a full range receiver, so up to 2 kilometers of range, so plenty of range for a race quad like this. Then let's have a look at the wiring of the quad. It's a pretty easy, pretty simple wiring because of the 4-in-1 Esc, because of no PDB on it. That makes it pretty simple, and let's get a closer look. We started a battery cable. We have these battery cables with 3.5 millimeter gold plugs, which go straight to the battery pin on the Esc, on the 4-in-1 Esc. From here we go with power directly to the FC with red and black, and also red and black directly to the Pololo step down regulator for 12 volt, which sits in the front of the frame. Then we have the buzzer, which is on the other side of the power cables, also black and red to the buzzer. And on these 3 pins we have the S-bus connector, ground, signal and positive, 5 volt. And that's almost it of the FC. Then there's the 4-in-1 Esc wired up to the FC. This is in front here on the lower side of the FC. This is why you can't see it, as I already described the wiring. It's a yellow, green, blue, orange and ground on the lower side of the FC, which gives you the correct order of the ESCs on your FC to work perfect with Betaflight. All the motors are wired up straight, and I just used BL Heli configurator to reverse the motors to the right direction. If you want inverted prop direction like I have it, so all the props will spin outwards, and just to avoid dirt on your FPV lens, you have to reverse motor 1 and 4, and motor 2 and 3 have to be in regular direction and in BL Heli software. And if you want standard or traditional spinning motors like this, they turn inside, then you have to go the opposite. That means ESC 1 and 4 in BL Heli configurator should be normal and direction, and motor 2 and 3 or ESC 2 and 3 should be reverse direction. And yeah, that's almost it for wiring. There is just the last thing from Pololo step down. Later we go with red and black to the VTX, and also from the VTX, red and black from the same wire, we go to the FPV cam to power up the FPV cam, and for sure the yellow cable from the cam back to the VTX to get the FPV picture. Last but not least, we have the VTX, and this is a super cheap VTX from Ishin. It's the TX526, and there are a few things I like. There is no pigtail, so the mounting, how it's fixed on the frame, is also these 2 cable ties, the same cable ties I use to fix the antenna. They also hold the VTX in place. I just added on the top side between the VTX and the top plate a thick double-sided tape to give some additional strength to fix it well on the frame, but it sits pretty nice like this. You have this small display which shows you channel, band and VTX power, and there is one button set up, super easy to set up band frequency and band channel, and VTX power, and it runs perfect on 200 milliamps. On 600 milliamps you'll get in trouble because it's getting very hot and your picture is getting better than if you use it in 200 milliwatts. In 200 milliwatts it's super stable, great picture, and I really like the solution. There is something with the plug here. This doesn't fit extremely strong, so if you want to have it super strong, you can add some silicone or whatever to fix the plug more on the VTX. Just in case of a crash, it's possible that the plug comes out of the VTX, and then you won't have any more VTX picture. So that was all for today. My review for my current GEP-AX5 quad. If you liked the video, give me a thumb up, comment, share, subscribe, and as always, happy flying. Bye bye.